So here I have used, so we have to find the second derivative of this function, x ln x. So again, this function here we have x ln x. That means this is, we can use product rule here, x into ln x. So product rule is, firstly differentiate this function and keep this function, and then plus differentiate this function and keep this function. So derivative of x is 1. So 1 into ln x is ln x. And then derivative of ln x is 1 by x. And here we have x. So this x and x get cancelled. So we have ln x plus 1. Ln x plus 1. So here is ln x plus 1. And to find that, this is our this is the first derivative, okay? And to find the second derivative, you again differentiate this result, okay? You again differentiate this result. So now derivative of ln x plus 1. So ln x plus 1 is 1 by x, and derivative of 1 is 0, because derivative of a constant is 0, okay? So we get 1 by x. So this is our final result, or this is our second derivative of our main function. So Zakir and Nahid, do you understand?
Yeah.
Okay, now let's go to number 4. We have dy by we have derivative of. So again we had parametric equation. Like we had two equations. One was y equal to t cos t. So it was like this way: x is equal to t cos t, and y is equal to cos t. So this was our this was in the question. So you can see here we have two different functions, but they depend on the same variable t, right?
Yeah.
Right.
So you can, this is our parametric equation. So we have to differentiate. We have to differentiate these two functions with respect to t, or with respect to the common variable. So dy by dt, this will be sine. So what is our y? Dy by dt. So it is this is our y, t cos t, right? So we just implement chain rule here. We implement chain rule here. Sin t plus t into cos t. Cos t into cos t by dt. So y was, so I forgot the question. Maybe y was, guys, do you have the question?
Oh. I don't remember the question. So the thing is simple. Just differentiate the first function with respect to t. So it will make t cos t. Like this sin t and this sin t get cancelled, and you get t cos t. And then you differentiate the x with respect to t. So maybe x was sin t. X was minus sin t. Maybe. So minus sin t differentiate, it will be cos t. Yeah. T cos t by sin t. Maybe x was minus sin t and y was, I don't remember. Okay, let me see the note of our Laushi. So Laushi didn't give us the note, right? Right.
Okay, we can skip this. Okay, I will discuss it later on. So we already know
Okay.
how to solve a parametric equation, right? So now see the number 5. We have y minus sine t is equal to cos y. So this is a composite function, because you can see we cannot keep y on the left side. So we differentiate both sides with respect to x. Differentiate on the both side with respect to x. That means dy by dx and dx of sin x and dx of cos y. So the interesting part is here. So you can see we are differentiating y with respect to x. That means we cannot write we cannot write one here. We cannot write dx of y is equal to 1. We cannot write this, okay? So we have to write this way, y derivative. And dx of sin x will be cos x. So dx of sin x will be cos x. And dx of cos y. Again, we are differentiating y with respect to x. So we cannot differentiate y with respect to x. That's why we have to use chain rule. So chain rule is derivative of outer function multiply derivative of inner function. So outer function is cos y. So derivative of cos y is minus sin y. And inner function is only y. So derivative of y is y derivative. Okay. So now just take this cos x on the right side and take this sin y into y on the left side. So we get y derivative plus sin y into y derivative is equal to cos x. So just put y on the left side. Put y derivative on the left side. Like you just take common here. You just take y common. So y derivative common. So it will make on plus sin y. On plus sin y is equal to cos x, right? So now take this down here. So it will make cos x by on plus sin y. So Nahid, can you understand? Zakira?
Yeah.
Is it difficult?
Yes, it is.
Okay, so do you remember the rule? If we are differentiating some,
Yeah.
if we are differentiating
Y.
y with respect to x,
X.
we cannot
Yes.
differentiate it. So we have to use chain rule.
Then
We have to use chain rule.
yeah.
So chain rule is derivative of outer function multiply derivative of inner function.
Yeah.
Okay. And here you can see again, we cannot differentiate y with respect to x. That's why we put down here y derivative. And what is ddx of x? ddx of x? Nahid and Zakira, can you tell me what is ddx of x?
1.
1, right. And what is ddx of y?
Y. It should be.
It should be y derivative, right?
Yeah.
It should be y derivative. Okay. So I think you can understand maybe 50%.
50%.
Yeah. So no problem. By practicing, we can understand more. Okay.
Yeah.
So now let's go to the main part or lecture 6. Maybe we have to make another. No, I can cover it. So I can cover it simply. Okay. So I will make it very simple. So for example, here is a function. Here is a mountain. So the very top point will be the very top point, and the very bottom. The very top point is here, and the very bottom point is here, right? Here is the very bottom point, and here is the very top point.
So these 2 points are called global extrema. They are called
Global extrema.
And you can see another some little mountain here. This is one mountain. This is another one little mountain. Okay, so they are local extrema. Okay, they are local extrema. So to find the global extrema, so let's see a real example. So to find a local extrema, we have to see 3 things. We have to look at 3 in the 3 point. We have to look at 3 points. Number one is interior point where derivative of the function will be 0. That means here is a function y is equal to x square. So if we derivative this function, it will be 2x. So we have to write 2x is equal to 0. 2x is equal to 0.
0.
So in this point, there could be a potential global extrema. Okay, there could be a potential global extrema. And another thing is in the interior point where f dash is undefined. For example, if a function y is equal to modulus x, here in this position, here where x is equal to 0, we already proved that this 0 point this is not differentiable, right? This is not differentiable. So here differentiable means f derivative, right? So here it is undefined. So these 2 are called critical point. F dash is equal to 0 and f dash is undefined. These 2 are called critical point. And there is another thing that is called in point. So in point is very simple. You just substitute the interval. Okay, you just substitute the interval. That means, for example, we have function f of x is equal to 2x. Sorry, f of x is equal to x squared. Here is our function. F of x is equal to x squared. So you just substitute minus 2 here. Substitute minus 2 here. And again on here, okay? So you can see I substitute minus 2 here and on here. So it will make minus 2 squared. That means 4. And it will make on a square, that means 1. So these 2 points, like f of minus 2 is equal to 4 and f of 1 is equal to 1. These 2 points is our in point. And f dash is equal to 0 and f dash is equal to undefined. This 2 point is our critical point, okay? So extreme value. So extreme value will be the highest point and the lowest point. Okay. For example, here we have the highest point. Highest point is 4, right? And the lowest point is 0. See here, lowest point is 0 and highest point is 4. Okay. Thus the extreme values are f of minus 2 is equal to 4 and f of 0 is equal to 0. Oh, okay. So I didn't show you f of 0. So for this particular function, we have to find the derivative. So derivative is 2x, right?
Yeah.
This was the formula, but this was not for this function. This was the formula, okay? So our function is f of x is equal to x squared. So you find the derivative x squared. So derivative of x squared will be 2x. And now if you substitute 0 here, like we have to write this way, 2x is equal to 0. Because according to our formula, we know that derivative of x is equal to derivative of this function will be 0, right? So derivative of this function is 2x. And according to our formula, it will be
0. So x will be 0 by 2. So 0 by 2 means 0.
Yeah.
So Nahid, Zakira, can you understand?
Yes.
So we got our extreme values. This is f of minus 2 is equal to 4 and f of 0 is equal to 0. So now see another example. We have, let's see some simple example. So number 1, we have to find the global extrema where f of x is equal to 4 minus x square, where f of x is equal to 4 minus x square, where our interval is x is greater than or equal to minus 3 and x is less than or equal to 1. Okay. So now let's find, so we have to do, now we have to find the derivative of this function and we have to write its derivative is equal to 0. And then we have to find f of minus 3 and also f of 1. So here is the answer. Firstly, we find the derivative of the function. So it will be minus 2x. You can see our function was 4 minus x squared. 4 minus x squared. So derivative of 4 minus x squared it will be, so derivative of this constant will be 0 and derivative of x squared is 2x. Sorry, and here is minus. Here is minus and derivative of minus x squared is minus 2x. So this is our minus 2x. And according to our formula, we know that our critical point is derivative of f is equal to 0. So we can write minus 2x is equal to 0. So then x will be also 0. Minus 2x is equal to 0. So you just take this minus 2 here. So it will be x is equal to 0 by minus 2 is equal to 0. Okay. And now we have to find the in point value. So this is our extreme value. This is our extreme value, okay? This is our extreme value. So our in point value will be f of minus 3 and f of 1. So f of minus 3 will be, this is our function, 4 minus x squared. Our function is 4 minus x squared, okay. So f of minus 3 will be 4 minus 3 squared. That means 4 minus 9. And 4 minus 9 is minus 5. And f of 1 will be 4 minus 1 squared. That means 4 minus 1 or 3. Okay. So you can see the highest value here is 4. And the lowest value is minus 5. So this 2 is our solution. Or this 2 is our global extrema. So Zakira, do you understand? Nahid? Hello, Nahid. Nahid, can you hear me? Zakira, can you hear me?
Yeah, I can. I don't know. My mic is mute. So I was answering you, but
So did you understand?
I have a question. Yeah,
Yeah.
I understand, but I have a question.
Yeah.
We have situation. Wait, I can draw.
4 minus x squared. Y is equal to 4 minus x squared. Yeah, ask me.
Yeah. First, we find this function here. Okay. this and this is the answer, right?
Can you mark? Can you mark on the screen?
Yeah, I'm doing. Don't you see?
Yes, I can see. Yes, yes. So here, yeah, first
Okay.
we have to differentiate our main function. So
Yeah,
and
and the second.
according to formula, our critical point is either here or
Yeah,
here, right?
yeah,
So what is it?
undefined. Yeah. So and this according to the situation we find a function of -3. All right. And the second
Yeah,
function
the function of
was
-3. This is in point value. Okay, function of function of
yeah,
-3 and function of 1. These two things are our
yeah, all right.
value.
Yeah, yeah. I was confused about this. I wasn't see this that we've
And this
solved
part,
this.
this
All
is
right.
our
I
critical.
understand. Okay.
So to find the global extrema means the highest point and the lowest point. Okay, global
Yeah, yeah.
extrema means the highest point and the lowest point. So here our highest point is f of 0. We also need to find f of 0. Okay,
Yeah.
we have to
Okay,
find
okay.
derivative of f equal to 0 and also f of 0 and also our in point values.
Okay, okay, okay.
So on thing, two thing, three thing, and fourth thing.
Okay.
So our f of 0 is 4.
Yeah.
But remember, f of 0, you have to put this value here, not here, okay? Not here. Do not
Okay.
make mistake. So you can see our highest value is 4 and lowest value is -5. That's why our global extrema are f of 0 equal to 4 and f of -3 is equal to -5. So maybe here is everything that was discussed from lecture 6 and lecture 5. So you can see that if you do not understand lecture 5, you can't understand lecture 6, right?
Yeah.
Because here is some more complex example.
Okay. I can understand totally.
So derivative of this function will be 2x to the power -3. And according
Yeah.
to our formula, our critical point will be this point, right? So this will be 0. So this will be 0. So x is undefined. So x is undefined. So now we have to find the in point value. So in point value is half and 2. Look at the question here. In point value is half and 2, right?
Right.
So you find f of half and f of 2. So it will make -4 and -1/4. So our global extrema is -1/4.
Okay, okay. Right.
F of 2 is equal to, okay, so maybe our global extrema is maybe it will be -4 and -1/4. Okay, these two things,
Yeah.
-4 and -1/4. And Yunus told another thing, right? Like if you look at the question, here our interval
Yeah.
is from half to +2. You look at
Yeah.
our interval is from half to 1/2 to +2, right? But
Right.
here we found 0, or here we are calculating 0. So 0 is not
Yeah.
included. Oh no. So 0 is not included in this interval. 0 is not included in this interval. So that's why this function is not defined, or our f of 0 is not defined. So our extreme value is this one and this one, okay?
Okay.
So maybe we can close this here. Stop